That is, but it's mission possible because we can do this stuff. So I'm going to show you some notation. What we have is, if I have two functions, f of x and g of x. Okay, that's the name of the function. It's a function that depends on x, and its name is f. This is a function that depends on x, its name is g. I'm going to do some simple functions that we've dealt with before. Two functions. Can you guys graph both of those functions?
Should be able to.
Okay. Yeah. That's just our memorized quadratic graph. Doing what with it? Up 1. This is a linear function that is shifted up 3. Okay. So what we need to do is we need to figure out what is, if h of x is equal to so we're going to say h of x is equal to f plus g of x. What do you think this means I'm going to do here? Multiply x into both of these. I can't multiply x times a name. This right here is one form you may see it as. You may see f plus g of x. This is the same thing as doing f of x plus g of x. So if I have a function that's done by adding two functions together, one form you may see it is the two function names in parentheses with the operation in between them with the x on the outside. The other way you can think about it is breaking them up. So the function of a sum, is the same thing as the sum of the two functions. Does that make sense? So in my case, what is f of x plus g of x? Well, it's f of x plus g of x. And we just do the math. Any questions on how I came up with f of x plus g of x? Did a chapter 1 work with it? If I can add two functions together, I can also subtract them. So a subtraction of two functions is the difference of the two. So I write the first function down minus the second function. X squared is the only x squared. Minus x. 1 minus 3 is negative 2. And that would be my answer. Anything hard here yet? Yes? No? No? So it's easy? So far, I mean, that's what I said, just yet. This concept right now, adding and subtracting one function from another, it's just doing chapter 1 problems with polynomials so far, right? Okay.
Now what's the other?
Well, if we can add and subtract them, let's try multiplication and division. Okay, so multiplication, f times g of x is equal to f of x times g of x, which means, hey, write the two binomials together and out. X times x squared, x times x squared. Good job, David. X squared times 3. 1 times x and 1 times 3. Okay. The next one we have to put a little caveat on. F over g of x is equal to f of x over g of x, such that g of x is not equal to what? 0. So I have to put a restriction is that I'm not allowed to divide by 0. And we've always put that restriction on that anytime I have a variable type thing in the denominator, we always say it can't be 0.
So we do it like syntax.
We don't even have to do that. We don't have to do the long division portion of it. All we're going to do is we're going to write f of x over g of x. And if nothing factors out to cancel out, you are done. I don't need you to come up with a number plus a remainder. That is its answer right there. Now, there will be some that you could simplify. For example, if you ended up with, let's say you had x squared minus 9 over x plus 3. Isn't this x plus 3 times x minus 3? So the x plus 3's would cancel. And this would leave you with x minus 3 with x not equaling negative 3. Remember, you can't have that equal to 0. You still have to put that caveat even if you were to cancel out the x plus 3 out of that part. So we're not going to do any major long division or anything like that with this. We are just going to do whatever the bare bones form of simplification is. And you're going to be able to tell if it's going to simplify. I'm not going to give you any really huge things to play around with. We're going to be dealing with basic quadratics, basic linear functions, and stuff like that. Okay? These are basic arithmetic operators. We have one more operator that we need to talk about. Nope. It's called the composition of functions. So I'm going to write down the composition of functions. So we're going to write down, and I'm going to write the words on top of it. This is f composed with, it's not the letter O, it's a little circle. It's not a solid dot like a multiplication symbol. That's read as composed with G. Okay? That is the one way to write it. The second way to write it is as f of G of x. F of G of x. These two mean the exact same thing. If I see it in this form, the first thing I do is I write it in this form because this tells me what to do. This tells me to perform the functions. Which function am I going to perform first here, f or g? G, because it's inside the parentheses. Basically, what this composition symbol is telling you is to perform the functions in right to left order. And if you write it as f of g of x, you can actually see that. So first thing you want to do is you want to do what's in the parentheses. Okay, so basically, if we were going to evaluate this, we would do what was in the parentheses first. Now I'm going to tell you how you're physically going to write this. First thing you're going to do is you're going to write down the outside function. Which one's outside? Okay, so we're going to write the outside function. Except where there's an x, you're going to put parentheses. So my first step here is to write down my outside function, which is f. Where there's an x, I'm going to put parentheses. Any questions on my first step? What do you think I'm going to put in the parentheses? I just had an x there. So in parentheses, put the inside function. So I would end up with x plus 3 squared plus 1. And step 3, simplify. Now, if I were asked to graph this function, I would leave it in this form to graph it, because this is just a quadratic that has been shifted 3 to the left and 1 up. Okay, it's really easy to see that one. If I were to simplify this, this would be x squared plus 6x plus 9 plus 1, which is 10. Any questions at all on that first composition of functions? So, please turn your books to page 182. Actually, I want you to go to 183. Yeah. And we are going to do problems 8, 9, 10, and 11. But we are going to do them, we're also going to add 2 things to it. So first thing we're going to do is we're going to write down what f of x is, what g of x is. So on that problem, what do they tell me f of x is? 3x minus 8. What's g of x?
2x squared.
Okay. So if I want to find 2 things. I want to find f of g of x. The other thing I want to find is I want to find g of f. So my rules. It says to write down the outside function, except where there's an x, put parentheses. So I'm going to write 3 parentheses minus 8. Inside the parentheses, I write the inside function. Simplify. 3 times 2 is 6. So I now have what f of g of x is, or f composed with g. Because some of the problems they are asking us what g of f of a number is, we're going to do the outside function. Except where there's an x, we're going to put parentheses. So it says to write down 2 something squared. In the parentheses, write the inside function. 3x minus 8. Can square this out. That would be 9x squared. 2 is 18x squared. Negative 8 times 3 is negative 24. Times 2 is negative 40x. And 8 times negative 8 is positive 64. Times 2 is 128. Any questions on composing those 2 things? What do you notice about those 2 compositions? Do they have the same answers? No. So be careful, because composition is not necessarily commutative. It's only commutative in special cases, which we'll get to tomorrow. So now let's look at problem 8. It says it wants to know what g of f of 5 is. They want g of f of 5. Yes?
On that last one, aren't you supposed to do like 2 times 8, 16?
No, I can't. No. I have to square this first.
Yeah.
3 times 3 is 9. X times x is x squared. 9x squared times 2 is 18x squared.
On the middle part.
Okay? 8 times, multiply by 2 and then multiply by 2 again? Yes. I forgot to multiply it by 2. 96. The first one. Yeah, that one's 96. Negative 24 times 2 is negative 48 times another 2 is negative 96. So 2 ways to do this problem. G of f of 5. The first way is to find out what g of f of x is and plug a 5 into this function and then evaluate it. Or what was the words I said? A composition says to perform function rules from what to what? Right to left. Well, f of 5. That means put a 5 in here. So if you want to do it this method, just do what's in the parentheses first. F of 5 is 15 minus 8, which is 7. Now I want to know what g of 7 is. That means 7 in here. 7 squared is times 2, 98. So if I ask you what f of g of x or g of f of x is, I do need the polynomial at the outside or whatever rational function. If you're evaluating a single digit, sometimes it's easier to evaluate the single digit keeping them separate. But remember, you go in right to left order. You go from inside the parentheses to the outside parentheses. So next one, f of g of 5. So what am I going to evaluate first? G of 5. Put a 5 in here. 5 squared is 25. 25 times 2 is 50. So I now want to do f of 50. 150 minus 8. So let's put a 5 in here. 5 squared, 25, times 6, 150. 150 minus 8, 142. So you can do it either plugging it into the composed function or you can do each step individually. I'm going to do f of 5. Uh-oh. Somebody walk me through this one. What am I going to do first?
F of 5.
F of 5 is what?
50.
F of 5 is 7. So now I'm going to do f of 7, which is 21 minus 8, which is 13. 21 minus 8 is 13. And the last one we're going to do, g of 5. G of 5 we got was 50. This one's going to be fun. What's 50 squared?
25,000. Or is it 2,500?
It's 2,500 times 2.
That would be 5,000.
5,000. And you guys are way off by your 10 digits today.
I had to think about this. They didn't have
Those guys, me, the rest of us ain't even talking.
Okay.
They was like, hell.
So let's talk about both of these functions. What's the domain of this function? What numbers can I put in for x?
Is it into all real numbers?
So the domain of f is all real numbers. What is the range of this function?
Negative infinity to infinity.
So again, all real numbers. We should know that any line that is not vertical, its range is all real numbers. That graph, all real numbers. Notice I'm taking the outputs of this function and putting them into this function if I'm doing f of g of x. What is the domain of this one going to be? Domain of a polynomial function.
Exact same.
All real numbers. Now, if I would have had a restricted if my range on this one would have been smaller than all real numbers, I couldn't use the domain of all real numbers into this function because it wouldn't have got those as outputs. And we're going to see an example like that. What's the range of this function?
Negative infinity.
No, it isn't. What y values does that function go? What's that graph look like?
0 to positive infinity.
0 to positive infinity. This is just a parabola.
Yeah.
Center vertex at the origin that's really steep.
Yeah.
So its range is from 0 with a solid dot to positive infinity.
Solid dot.
Yeah, solid dot because you touch it.
Solid bracket.
I'm thinking weird stuff.
I tightened my belt all the way in. I don't think it's very good when I stand up.
You tied it?
I tightened it as much as I could.
Oh, I thought
Please
you
turn your
said
books to
you
page
tied it.
185.
I don't want to stand up, so flip the page.
Okay.
185. H of x equals the cube root of x plus 2.
What? You can't
No,
just go
40.
ahead and say stuff
Number
like that.
40.
Oh, 40. Thank you. He can't just go ahead and say stuff like that. He scares me.
I want to find an f of x and g of x such that f of x, h of x is equal to f of g of x. So the words I had you do when we were evaluating compositions of functions, I said we'd write down the outside function, and except where there's an x, we put parentheses, and inside the parentheses, we would put the inside function. The outside function was f. The inside function was g. What would be the inside function of the cube root of x plus 2?
X plus 2?
X plus 2.
And then the f would be the cube root
Of what?
of x plus 2?
No.
Of something? X.
So let's follow the rules. Write down the outside function, except where there's an x, put parentheses. Did I follow the first step?
Would it literally be?
Did I follow the first step?
Yes.
And inside the parentheses, write down the inside function. What we're doing is we're taking something that is a composition and trying to break it down into its parent parts. For those of you that are going into college algebra and calculus, the ability to break down compositions of functions into their parent parts is a very, very strong skill to use. Because I'll tell you, in calculus, a lot of the stuff that we deal with is compositions of functions and how to undo compositions of functions.
You should do a day calculus.
So, 41.
No, they get a test or something.
41 says h of x is equal to, there's a lot of different ways I could write this one. 3x squared plus 7. I want an f and a g that will make this work.
Wait, what? What'd
So,
you do?
this is 41.
Oh, okay.
I want an f, and I want a g such that when I compose f with g of x, I get back to h. Somebody give me an inside function. There's a lot of ways to do this. I know of 3 of them right off the top of my head, 3 different combinations that would work for this.
Could it be like something like 3x parentheses x plus 7? Like
X
that type of stuff?
squared.
If you start like splitting it up like that and then do
You
weird
could
stuff.
do 3x because 3, it would make 7 have to be 21x.
So let's look at this. How about this? How about f of x is just 4 over x? What would g of x be?
It would be 3x.
It could be like what you did up there would bring in.
It would be 3x squared plus 7.
Yeah.
So write down the outside function, except where there's an x, put parentheses. Inside the parentheses, write the inside function. That's one possibility.
Yeah,
How about this
Yeah,
one?
friend.
How about 4 over x plus 7?
That's a trivial.
If this was f of x, what would my g of x be? Actually, not quite right. Yeah, that would work.
I'm sorry, I can't see it on the board.
It's right here. And that's reversed for you anyway. So if f of x is 4 over x plus 7, what would my g of x be? So that when I put g in, I would get back to 3x squared plus 7.
Hey, why is it reversed on the computer?
What do I have to substitute in for x to make that a 3x squared plus 7? I just said it. What do I have to
Yeah,
substitute
yeah.
it? There we go.
Yes. I don't know. That's what I was trying to.
Write down the outside function, except where there's an x, put parentheses. So put a parentheses here, and inside the parentheses, put the inside function.
Okay, so there was an inside to the inside of the function?
Yeah, I can do that.
It's called
I'm just
conception.
showing you. I told you, I know at least 3 different ways I can write this as a composition.
Okay.
How about this one? F of x equals 4 over 3x plus 7. What would my g of x be in this case? What would I have to replace x with to get 3x squared plus 7 in the bottom?
X squared.
There you go.
Dude, I wonder how like college math professors teach.
Multiple ways for you to come up with the answer there.
Okay.
Any questions on section 3.3? Those were the challenge problems.
Good.
Jordan, just like imagine like advanced. Why are you listening?
Because we're recording this, David.
Oh, okay.
Because I want to send it to your mom.
Oh, I'm fine with saying this then. Okay.